Okay, so did anyone try out the homework problem? Okay, so today we'll be starting with the some theorems. So let's first start with the intersecting chords theorem and the tangent secant theorem. So what happens is that in the intersecting chords theorem, if there is a circle and two chords are intersecting, that is AB and CD are intersecting at the point E, then all we have is that AE times BE is equal to CE times DE. Okay, so how do you prove this? You basically join AC, DB, and you prove them that ACE triangle ACE is similar to triangle DBE and find out the ratio. Okay. Now coming to the tangent secant theorem. So if you have a circle, let's have a tangent and a secant from a point outside a point P. So let's take 2 seconds. Suppose this is the point P. This is the point Q where it's tangent from the point P to this circle. And suppose this is the point A, this is the point B, this is C, this is D. Okay. Now all it says is that PQ square, that is the length of the tangent square, is equal to PA times PB, and which should also be equal to PC times PD. I mean, if we are done with proving this, then we are done with this also. That is another second. Okay, so how do we prove it? The idea is to join Q and A, and now if you prove that triangle PAQ is similar to triangle PQB, so yeah, try to do this and get this ratio from there, because you see that PAQ and PQB, they both have the side PQ, so that's where you'll be getting the PQ square. Okay, now let's move on to problems. Let's do a simple one first. Suppose I have an isosceles triangle ABC, So ABC is an isosceles triangle where AB is equal to AC and P is a point on BC. Now all you have to show is that, so let's join P, AB plus AP times AB minus AP is equal to BP times CP.
Power of this point.
Yes, can you be a little louder?
Sorry, my mic was muted.
Oh,
Is AP equal to AC?
AB equals to AC. B for Bombay. And P is any point on BC.
Sir, I think I have the solution. Maybe.
Okay. Yeah, please share.
So I draw a triangle. I draw a circle with center A passing through B and C.
With center as A passing through B and C. Okay. Let me draw it different on a different page. So the situation is something like this. Where A is the center of the bigger circle. Then,
So now use power of point from P. What is the power of point P with respect to the new circle?
okay, the power of the point B. So,
Not
with,
Pune. Power of point Pune.
okay, power of the point P with respect to the smaller circle or the bigger circle?
Bigger circle.
Bigger.
Circle. Circle with center A.
Okay. So the bigger circle. So So if I look at distance, Now, what are you taking the radius of that bigger circle? Like it's AB, so AP square
AB,
minus,
radius is
sorry, AB, yeah, AB is the radius of the bigger circle. So AB square minus AB square, right?
and it is equal to PB times PC, right? It is equal to PB times PC.
Is
This is
equal,
also power point is also PB times PC.
yeah, because those chords are intersecting. So PB times PC. Fine. Yeah, using power of the point, you are
This is
done.
what you are looking for, right?
This is a correct proof. Yes. So for those who do not know, is there someone who do not know power of a point? So you can try it out. Uh, you can try it out in a normal way also. So yes, we don't worry. We'll learn what is power of a point today. If you don't know, so uh, suppose you join this, and suppose this is I extend AP to the point D, and I name that point as D. Okay. Now these two angles are equal. That is because of the isosceles triangle, theta, theta. Okay. And now, can you also say that this angle will also be theta? Just simple angle chasing. AB. So this is simple, right? AB is subtending those two angles, ACB and ADB. Okay. So this is also theta. And now look at these two triangles, triangle ABP and triangle ADB. Okay. Now, are they similar? Anyone? So they both have the angle theta, right? And any more angle they have equal? One more angle?
Yes, angle BAP.
Angle at that point A, right? So this alpha angle. So they are similar. And from them, these two triangles, you'll be getting AB by AD is equal to AP by AB. And you are getting AB square is equal to AP times AD. And now, uh, AB square is equal to, so let's do one thing. Let's try to break AD into two parts, AP plus PD. And from there we get AP square plus AP times PD. And now AP times PD is equal to AB square minus AP square, and that's equals to AB plus AB minus AP. And we just learned the intersecting chords theorem, so this AP times PD is equal to BP times CP. Okay, so yeah, so this proof was much better.
Sir, in this proof, shouldn't it be AB square minus AP square?
So the part of a point definition is the distance of the point from the origin minus the radius square. So the part of the point is negative when it's when the point is inside the circle, and it's zero when the point is on the circle, and it's positive when it's outside of the circle. Okay.
Sir, I think it is what the person was saying was correct. I think we need to change the.
So you're saying here there will be a minus sign, BP minus PC, BP times PC?
Yes,
Yes,
sir.
sir.
Oh yes, that you can say yes. Okay. So suppose you have a triangle ABC, and there is a point X inside this triangle. Now okay, now I'm taking another point A dash on PX, and I'm drawing A dash B dash, which is parallel to AB, and this is meeting at, suppose this is the point B dash, and A dash C dash, which is parallel to AC, A dash C dash. So all you have to show is that B dash, C dash, R, Q are concyclic.
I think I have a method.
Okay.
Hello?
Yeah.
Yes, so what is happening is that so C dash X A dash is parallel. C dash X A dash is similar to AXC, right?
Okay. Triangle C dash.
X A dash is similar to triangle CXA.
Triangle B.
CXA. Chennai XA. Because of C dash A dash and AC parallelity.
Okay.
That is obvious, right?
Yeah.
Okay, moving on. So therefore, C dash A dash by AC is equal to X A dash by AX.
Okay. C dash A dash by AC is equal to AX. Oh, sorry. Which side are you taking? C dash X or A dash X?
C, X A X A dash X A dash by AX. X A dash and A dash X and AX.
A dash X and AX. Okay. Then
Similarly, B dash A dash by AB or AB by AB is
B
equal to A
dash
dash X by AX
B dash A dash.
by AB.
Okay. B dash A dash by AB
Is equal to A same thing. A dash X by AX. Because of similarity between X A dash B dash and X A B.
Okay.
Is it okay?
Fine. Then
Yes. Then we see that these are equal.
right.
So C dash A dash by AC equal to B dash A dash by AB.
Right.
Also, notice that C dash A dash X, this angle, C dash A dash X, this angle is equal to XAC.
C
Just
dash
mark it.
C dash A dash X. If this is theta,
Then, then XAC.
then X
XAC is also
theta. Yes. Then
X A dash B dash, X A dash B dash is equal to XAB. X A dash B dash is equal to XAB. So angle C dash A dash B dash is equal to angle BAC. B dash A dash C dash is equal to BAC.
right.
Right?
Right.
Therefore, triangle A dash B dash C dash is similar to ABC
Okay.
because they are because of SAS similarity, side angle side similarity.
So
Is that okay?
you have proved these two ratios and the included angle are equal, right? So
Yes.
that's how you're saying that they are similar. Okay. So
That
triangle
is a SAS similarity condition.
triangle ABC is similar to triangle A dash B dash C dash.
Okay.
Yeah.
Now, therefore, what happens is uh, C dash B dash is parallel. C dash B dash is parallel to BC.
Okay.
because those two sides are parallel and similar, so there must also be parallel.
Mm, fine.
If they are not parallel, the angles cannot be equal.
Yeah, so the angles are equal. So this is so this angle at C dash should be equal to the angle at C, right?
Ah,
So from there, can we prove that they should be parallel? Like,
okay. So produce C dash A dash in the direction of A dash.
C dash A dash in the direction of A.
In the direction of A dash.
Okay, fine.
So that angle it creates with BC, is also C. BC like this. No, the other angle, adjacent angle. This is C. This is equal to angle C.
Uh, so this is parallel to this. Yes, this is angle C.
And A dash, C dash, B dash by similarity is also equal to angle C.
Right. And so they are parallel.
So they are parallel. Parallelity proved.
Yes.
Now C dash B dash B. This angle C dash B dash B. C dash B dash B.
Wait. Yes. So let me write C dash B dash is parallel to BC. Yes. Then what?
C dash B dash B
C dash B dash B. This angle
is
will be
parallel to that angle. Absolutely. And of CRQ, angle CRQ is also equal to that angle.
CRQ. Okay. Let me join R and Q then. So CRQ. Okay. That is also equal to beta because subtended by QC.
Yes. Now what is C dash B dash Q?
C dash.
We have just proved it is cyclic quadrilateral.
C dash B dash Q.
Q is 180 minus B. So opposite angles sum up to 180. So cyclic quadrilateral.
Okay, so this is 180 minus beta,
Yeah.
and so B dash, C dash, R and Q. There, that is a cyclic one because opposite sides are summing to one. Angles are summing to 180 degree. Yeah, that's correct. Does anyone have any question? Okay. So let's move on to the next topic, that is the radical axis. So what is actually a radical axis? So basically when two circles are meeting, then if you join, so if they intersect at AB, then if you join AB, that's the radical axis. Or if they are touching each other, then it's the common tangent there. Or or if one is inside the other, then that common tangent is the radical axis. So that's that's how we define it. Now there is a theorem that is, suppose if three circles are mutually intersecting each other, then the three radical axes are either parallel or concurrent. So let me show you. The situation is something like this. You have the three circles. So the first circle and the second circle, they are making this as a radical axis. The second and the third one is making this one, and the second and the third, sorry, the first one and the third one. This is the second and the third one. So in this case, they are parallel. Like, we haven't still proved it, but I'm showing you the two situations. So another situation is something like this. So this is the first one. This is going from the second one. This is coming out from the third one. So these are the two situations. Either they are parallel or they are concurrent. So now, what is the idea of the proof? Does anyone know? So the idea of the proof is that uh, I so I don't have to prove the two cases. So I'll so these three lines, if they are parallel, then it's fine. And I'm going to prove that if they are not parallel, then they should be concurrent. Okay. So there are two cases that I'm dividing in. So whether it's it's parallel, and if it's not parallel, then they are concurrent. So if I just prove that not parallel means concurrent, so that obviously means that the other case is for the parallel. So which I don't have to prove. So that's the idea. That is, not parallel implies concurrent. Now, how do I do that? Any idea? Just look at the second figure. So it's something like the Seva and the Mene law, the converse. So what I'm going to do is I'm just going to cross out one of those lines. So since they are not parallel, so obviously the first two would go and intersect somewhere. So I'll say that let it be P. Okay. And
Sir, what if two are parallel and one isn't?
No, all three are parallel. Okay,
What,
yes. What if two are parallel and
one is not parallel to the other two.
yes? So, suppose you are saying that two are parallel and one is not parallel to the other. So that means at least two lines exist which are not parallel.
Okay, got it.
Okay, so then without loss of generality, I'll take those two lines and they intersect at P. And then what I'll do is I'll join the point P with the suppose so this the circles wherever they're intersecting, wherever that chord should have passed through, and I'll produce it. So these two points I'm joining, that is the point P and the two circles intersecting at that point. And now I'll produce it, and suppose I'll say that no, it's not meeting at that point, the other intersecting point where it should meet. So this point, okay. So and finally I'll try to show some contradiction and prove that both these points are the same. Okay, so the idea is that suppose let's name the points A, B, C, D, and E. This is F, and suppose this point is X. So I have to show that X is equal to F, and then I'll be done because EF is the radical axis. So now what I can use the tangent secant theorem because I see here the seconds. So I'll be having PA times PB is equal to PC times CD. Okay, and now this px is a straight line. Okay, so according to our hypothesis, this px is a straight line, and also you see that a b x and e. Okay, so a b x. So okay, let's do one thing. Let's take x to be on the second circle. So A, B, X, E, it's all these four points are on um, the second circle, and from there I'll have again this P A B P A times P B is equal to P E times P X. Okay, and furthermore, so I have this PE times PX is equal to PC times PD, PC times CD. Okay, now can you show that this X and F are the same? So PC times CD is equal to PE times PX, right? And what does this tell you? That this tells you that C, D, X, E are concyclic, and X must lie uh, on the circumcircle of triangle CDE. Okay, and thus the point X is now on the second circle. So similarly, it should be also present on the third circle, and there's only one possibility for X to be on the second circle as well as on the third circle, that is the point F. So that's the proof. Okay, Let me know if you have any query. Okay. Suppose you have a circle P and Q, and yeah, I'm explaining what are these. So O1 is the center of the first circle, O2 is the center of the second circle. The two circles are meeting at P and Q. Now this O1, and suppose this is the point A and this is the point B, this is the point C, this is the point D. Now O1A intersects the second circle at the point uh, B, and similarly O2C intersects the first circle at the point B. Now it's given that AB ACBD is concyclic. So it's drawn in such a way that is A, B, C, D are concyclic. All you have to show is that the circumcenter show that the circumcenter of triangle ABC lies on the line PQ. Is the problem clear?
Sir, actually, I know this previously from a problem I tried. Should I say or should I wait?
Oh, you have already done this, you're saying, right?
Yes.
Oh, okay. So then let me give you a new problem. Okay, so ABCD is a cyclic quadrilateral. Okay. All you have to show is that so if these are angles are alpha, beta, gamma, and delta, so then sine of alpha plus beta times sine of uh, beta plus gamma times sine of times sine of delta plus alpha is greater than equals to 4 times sine of angle 1, sine of angle 2, sine of angle 3 times sine of angle 4.
They're all multiplied on the left hand side.
Yeah, everything. So on the right hand side also, this is all multiplied, all the signs, and on the right hand side, it's also multiplied. Is
And
it clear?
what is one?
Oh, sorry, alpha. Alpha, beta, gamma, delta. Is it clear?
Okay, I'll try.
Okay, for the others, what about this one? So we have to show that the circumcenter of triangle ABC is lying on PQ. So let's join PQ, and also let's try to draw the circumcircle of triangle ABC. Okay, now when I'm drawing this circle, so notice here one thing, that is this. Okay, what are the radical axes? AB is one of the radical axes. PQ is another one. Okay, and it was given that ABCDs are concyclic, so this circle should also pass through D. So Just consider it as a circle, the dotted lines. Now, notice one thing, that this PQ, uh, this AB and CD, they are the radical axis and they should be concurrent. So, suppose they all meet at this point H. Okay, now you notice that this AB is perpendicular to the line. Suppose this is the center of, suppose O is the circumcenter. Okay, O is the circumcenter of this triangle, sorry, the circumcircle of triangle ABC. And then if I join all these centers, then all I can say is that I know that the radical axis and the lines joining the center, they will be perpendicular to each other. So AB is perpendicular to OO2 and CD is perpendicular to this O1O. And now, if you notice that this H is nothing but the orthocenter of triangle OO1O2, right? So now can you bring out something from there? So now can we somehow show that OH, if I join the point O with the point H, then that will be perpendicular to O1, O2. Okay, because I know already that PH or PQ is passing through the point H and is perpendicular to O1, O2. Okay, and if I somehow can show that when I join O and H and produce it, that is also perpendicular to O1, O2, then these two straight lines have to be the same. So because from the point H you can't have two different perpendiculars on the same line O1, O2. So that's the idea. Okay, so why is it so difficult? It's easy, right? Because if you, what happens, it's the O is H is the orthocenter, right, of the triangle O1, O2. So obviously if you join OH and produce it, it's going to be perpendicular on O1, O2. And so this red line and that PQ line should coincide, and that proves that you have O1 PQ. Is there any question? Okay. Next, coming to the power of a point. So this problem we'll solve it a little later. We need some more tools to solve it. Ryan, are you done with this one?
Yes, sir.
Oh, okay. So, I mean, what are the tools that you have used?
Tolerance theorem, sir.
Yes, yes, yes. So we need Tolerance theorem. So okay. So then, let me give another problem for you. So those who knows power of a point, Tolerance theorem, all this, they can try it out because I'm going to discuss those now. So you might not feel bored. ABC is a triangle. So ABC is an acute angle triangle, okay? And where O is the circumcenter of this circle. And now I have 2 points M and N on the two sides of this triangle such that O lies on MN. Okay, so this point is M, this point is N. This line is a variable line. So all I need is that M on Mn, O should lie. And now let's take the midpoint of this line Mn. So D is the midpoint. And I join MC and Bn, and I take the midpoint of MC and name it as F, and I take the midpoint of Bn and name it as E. So all I have to show is that O, D, E, F are concyclic. Let me know if the problem is clear. Okay, so now we'll go to the power of a point. Suppose I have a circle and I have a point outside. I drop a perpendicular, I join that point with the center of the circle. that's the point there. I draw a secant. So now, according to the definition, the power of a point with respect to a circle which is having radius r, suppose, then any point, it can be it can lie on the circle outside or inside. The power of point is defined to be the distance of the point from the center, its square, minus the radius square. So this is according to the definition. Okay. Now we are going to analyze two situations. That is when it's outside, and basically we are going to show that it's related to the tangent secant theorem and the intersecting chords theorem. So, and also when it lies inside, it's something like this. So okay, let's first talk about the outside part. So when it lies outside, then you can drop a tangent px, and let's join x with the point O. Then you see that this is perpendicular here, so px square is equal to the hypotenuse square, that is op square minus ox square, simple Pythagoras. And now by the tangent secant theorem, I know that px square is equal to this pc times pd. So pc times pd is equal to px square, and you see that ox is nothing but r, right, the radius. So op square minus r square. So what I see is that uh, pc times pd, or if there is any other secant, so then that will also work. So it's basically the ratio in which that secant is getting is touching the circle. So it's pc times pd. So we can relate the power of a point in this way also. Like, this is the definition of the basic definition, but if the point is lying outside, then we can relate it with the secant by this way. Okay. So this is the power of the point P, as well as this. Okay, now let's analyze the inside one, because we are not analyzing because it's zero basically. So now if P is inside, then what I can do is I'll have two chords which will intersect it. So suppose AB and the other one is CD. And now what I'll do is, suppose the center is at O, sorry, O, and now I'll join OP, and I'll draw a line, or basically I'll draw a line which is perpendicular to OP and passing through P. And so this is perpendicular. So this is the construction I'm taking. So let that line then, or that chord be EF, which is perpendicular to OP. Okay. Now what I can say is that if I join OE, then I can say that OP square is equal to OE square, the hypotenuse square, minus PE square. And by the intersecting chords theorem, what I have is that PA times PB is equal to PC times PD, and that is equal to okay. So PC PC times PD is equal to PA times PB. This is I'm getting from the intersecting chords theorem. But uh, can I also write that this is also equal to PE square? Anyone? This is simple. Can I write this? So if I once I write this, then PE square is nothing but OE square minus OP square. Right, and so OE is nothing but the radius of the circle R square minus OP square, and so I'll have OP square minus R square, I mean multiplied by a negative 1. So that's the idea. But how can I say that PA times PB is equal to PE square or something? Or maybe you can get some similar triangles. Okay. Now look at this. That is, uh, can you write that PC times PD is also equal to, so this is also a chord EF, right? So PE times PF, I can say that this is also equal to this PE times PF. And now this is simple, right? Okay, what can you say about the length of PE and PF? Anyone? Suppose I join O and F. This is 90, this is 90, right? Fine. And this is R, the radius. These two are radius. And so these two angles will also be equal, theta, theta. And OP is common, so these two triangles are congruent, right? So P is the midpoint. So this, I mean, these basic things you should be knowing. So, so this is equals to PE square then, and P square is equal to this. So what we get is basically the power of a point, that is OP square minus R square, is equal to negative of PA times PB or negative of PC times PD. So any chord will do. So when this is lying inside, so that's the thing. So when the point lies inside the circle, it's the part of the point is negative. Okay. And one more result that we need is the Tolerance theorem. This is also very important. So what does the Tolerance theorem tell us? That suppose you have a quadrilateral. So in a quadrilateral ABCD, AB times CD plus BC times AD is greater than equals to AC times BD, and the equality holds if and only if ABCD is cyclic. So suppose this is my quadrilateral ABCD. Now the idea of the proof is that so try to first understand that it's talking about AB times CD. So the product sum of product of two opposite sides is greater than the product of the diagonals. So now the idea is that you choose a point P such that angle AB uh, sorry, such that angle ABD is equal to angle CBP, and angle ADB is equal to angle BCP. So if this is theta, then this is theta, and if this is alpha, then this is alpha. Okay, that's how I'm taking the point P, that those angles are theta and alpha. And now, so obviously two angles are the same, so I'll have a triangle ABD to be similar to triangle PBC, and from there I'll get AB by BD is equal to BP times BC, and from there uh, AB, yeah, times BD. Okay, and also look at this, that is AD by BD is equal to PC times BC. Okay, And now from here I get AD times BC is equal to BD times PC. And from this ratio I can also try and get another pair of similar triangles, that is triangle ABP. And so I mean this triangle ABP and similar to triangle DBC. Okay, so why is this? Because angle, look at angle ABP. So that is equal to sum of two angles ABD plus angle PBD, and that is equal to angle CBP plus angle PBD, which is also equal to angle CBD. Okay, and so from uh, this ratio and these two angles are getting equal, the included one, so we say that these two triangles are similar. And from there what I get is AB over AP is equal to BD over CD. And so it's AB times CD is equal to AP times BD. And now if I add these two, that is I have here AB times CD, and I was having here AD times BC here. So okay, I'm writing here. So adding them, I'll be getting AB times CD plus BC times AD is equal to AP times BD plus BD times PC. And this is further equal to, so what I can say is that this I have BD, so let's take BD common, so I'll have BD times AP plus PC. And now look at AP plus PC. I can say that that is greater than AC because of the triangle inequality, and if suppose P lies on AC, then they will be equal. So it's greater than equals to BD times AC. Okay, and so we are done. That is, this sum is greater than equals to BD times AC. Is that clear? Now we can move to the problems. Okay, anyone done with the previous one? This one? ODEF concyclic? Ryan, are you done with this one, the second problem?
No, sir.
Oh, okay, fine. So yeah, let me then discuss the first one and then come back to that. So yes, now give this problem a thought. Like now you know Ptolemy's theorem. Was there any question regarding what we just discussed, proved? So your hint would be to try with this sine rule. So let's join AC. And now look at this sine alpha plus beta. So sine alpha plus beta by, now I'm working on triangle ABC. So by AC will be equal to 1 by 2r, which is where r is the circumradius of uh, sorry, the radius of the circumcircle of triangle ABC. And now here you see every triangle that you take, they have the same circumcircle because ABCD is concyclic, and that's why the same the same radius we are having for every triangle, and that's going to connect us with all those sine alpha plus beta, sine beta plus gamma, and all those things. So I can write this as AC over 2R. Similarly, try to get the others like sine of gamma plus delta is again AC by 2R. And now the question is about the other pairs like alpha. I'm done with this alpha beta, alpha plus beta, and gamma plus delta. Now what about beta plus delta? So the question is, how do we get beta plus delta? Or alpha plus delta? Any idea? Okay, so you have to use a little bit of trigonometry here. So suppose if I'm working with beta plus gamma, and suppose this is the angle C. So I can say that sine of beta plus gamma is equal to sine of
Sir, you
1,
do not require trigonometry.
1. Okay, so I was using this beta plus gamma is equals to 180 minus angle C, so that will be equal to angle C. And so I'll relate with BD, relate it to BD now. So how are you relating that with BD, or suppose
But,
any
sir, I am finding out angle CAD and angle CAB.
CAD and
CAB.
by the same arc subtending as equal angles you are
Yes,
doing
yes,
that.
yes, yes.
Okay, yes, you can also do that anyway.
That is, so angle BAD becomes beta plus gamma.
BAD becomes beta plus gamma. Yes, you can also do that. That is also fine. So this is so this BC is subtending gamma, so this will be gamma, and this CD is subtending beta, so this will be beta. And here also similarly, this angle here is being subtended by AB, and AB is subtending delta. So this is delta and this is alpha. Okay, so in that way also you can go. So now all I have is that sine of beta plus gamma is equal to, so if you are working with triangle ABD, then it's nothing but beta plus gamma, the opposite is 180 BD, the opposite side is BD divided by sine of 2R, and the last one, that is sine of alpha plus delta, is equal to again BD by 2R. Now let's replace them in the equation. So I have the left hand side of the inequality. So I'll just try to replace them. So I'm getting AC square times BD square is equal to 2R square. And what about the right hand side? How do I get those ratios, sine alpha, sine beta, sine gamma, sine delta? So for them, like suppose let's work with sine alpha. So what will be sine alpha? Sine alpha will be, so these are angles. Yeah, so sine alpha would be AD over, so I have to now relate them with this. So if I want to use the Tolerance theorem, I have to somehow relate them with the sum of the product of the two opposite sides. So so that means that's why I'm taking AD over 2R. Again, that ABD also have the same circumcircle, and similarly the others, sine of angle beta is CD by 2R, sine of angle gamma is BC by 2R, and what else, sine of delta AB by 2R. So all I have to show is that this is greater than equals to 4 times. Now I replace those, so AD, CD, BC, AB, and they would be by 2R 4 to the power 4. Now how do I prove it? Now you see that we can apply now the Tolerance theorem. So I'm rubbing this portion out. So I have a cyclic quadrilateral. So the in the Tolerance theorem, I'll have the equality. So Tolerance theorem will give me BD times AC is equal to AB times CD plus BC times AD. Right?
I think the 2R should cancel. So both sides should be power 4, I think.
Oh, sorry, I think I made a mistake there. Oh yes, 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 yes. So that's a product of the four. So all those four were having 2 hours so each. So it's four. So this getting cancelled out, and so I'm getting. So I have to basically prove AC square times BD square is greater than equals to 4 times AD. Also all those product CD, BC, AB. Okay. Now, suppose AC square times BD square, I can just square. So this is I'm getting by Tolerance theorem. The equality is holding because I have a cyclic one. Okay, so now I square both the sides. So I already get AC square times BD square. Now I have to prove that that is greater than equals to 4 times AD, CD, BC, AB. So that's very simple. This is just algebra. Like suppose if you have a square where A plus B whole square, so you all you have to just prove is that this is greater than equals to 4 times uh, yeah 4 times no, wait, just a second. Yeah, sorry, yes. So this is I'm taking as A, this is I'm taking as B, so A plus B whole square is greater than equals to 4 times AB. Now is this true? Yes, because if you take everything on one side, so it's A minus B whole square, so which is greater than equals to 0. Okay, so I'm done. Any question? Now going to the next one. For the next one, the idea is that I have to prove that all those points are concyclic. So what I'm going to do is I'm going to take a circle which is passing through DEF, and I'll say that. So basically, I'm taking these 3 points DEF, and I'm drawing the circumcircle of that triangle DEF. Okay, and now uh, my hypothesis will be that okay, so it's not the other point where that circle is cutting MN, so let that be O dash. So that's not O, let it be O dash, and we'll finally show that O dash is equal to O. Fine. Now let's join all these things. D D E D F F E and also O dash F O dash E O dash. Okay. Now let's trace some angles. That is okay. So this is the angle subtended by EF. So that is suppose alpha. This is also alpha. So I'm writing it down. They are very small. So EDF is equal to EO dash F is equal to alpha. And because uh, all those O dash with EDF are concyclic. Okay. And Now I'll also be using the midpoint theorem because I have midpoints. So remember that D, E, F were the midpoints of the sides MN, BN and MC respectively. So from there, I can say that in triangle MNB, if I apply the midpoint theorem, so DE is parallel to MB or maybe AB. So DE is parallel to AB, midpoint theorem. Okay, and similarly, I'll also have DF to be parallel to AC because in the triangle MNC, I have D and F to be the midpoint. So DF will be parallel to AC, and so I'll have angle. Uh, Now these parallel lines will help me to trace some angle. So now look at angle. This angle. Look at angle EDF, the alpha. Okay. Now, can you also prove that the angle at the vertex A is also alpha? DE is parallel to
Yes, I can
AB?
prove. I can prove.
Yes. So, how do you prove that?
Yes, I can state it directly, right?
Yeah. So, if it's so let's extend it. So, if some confusion is there regarding that, oh sorry, they are basically not becoming parallel because of my drawing. So, suppose for the time being that this is something like parallel, this is a straight line. Okay, that is ED. That's the line which is parallel to AB, and now you extend this transversal FD, and that FD is parallel to AC. So this is parallel to this, and this is parallel to this. And so what can you say about, so this will be angle alpha, and so that the angle at the vertex will also be equal to alpha. Okay, so I'm removing all those things. If anyone not convinced, let me know. Alpha. Okay, so and similarly, suppose look at triangle, angle O dash EF. So I'm talking about this angle O dash EF, angle O dash EF. So that is, suppose if it is beta, then O dash DF will also be beta because subtended by O dash F is equal to O dash DF, and those are equal to beta. And also now look at the angle ANM. I'm talking about this angle ANM. Can I say that that is also beta? So just extend DF, you'll get it. Okay. So DF, that line is parallel to AC, and DN is the transversal. And so this angle here is beta, and so that angle will also be beta there. Fine. Okay, and finally, so we get something, that is, we get two triangles to be similar, O dash E F, which is similar to triangle ANM. Because O dash EF has the angle alpha and the angle beta, and triangle ANM also have angle alpha and angle beta. So from there I'll get some ratio. Now, okay, now also notice that this O dash DEF, that is concyclic, right? So I can apply the Tolerance theorem there. So, and yes, from these two triangles, what I'll be extracting is what I need in the Tolerance theorem. So let's see. Uh, so I keep this aside for now. Now I'll draw the Tolerance theorem. So I'll write the Tolerance theorem. So that is O dash D times EF, and the other two opposite sides are O dash F times ED. D. And that is equal to equality because it's a cyclic one, and the diagonals O dash E df. Okay, now I'll just take O dash D on one side and bring everything on the other side. So it's O dash E by EF times df minus O dash F by EF times D. Okay, and now I need O dash E by EF and O dash F by EF. So then I'm going to use these two triangles, which I have already proved them to be similar. So from those two similar triangles, I get O dash E by EF is equal to AN by MN, and O dash F is equal to EF is equal to AM by MN. Any doubt? Okay. Yes, any doubt so far? Okay, now, so I'll be getting then, now I'll replace those ratios here. So this is O dash D is equal to, I'll take the 1 over Mn common, I'll have An times Df minus Am times De. Okay, and now I know that this Df, again I'll use the midpoint theorem. Df is uh, half of Dm, right? So this is equal to 1 over 2 Mn. So I'm taking the half common.
The df is not half of bn.
Sorry. Cn. sorry, yeah, the other one is half of that is DE is half of MB, right? Yes.
Yeah.
So AN times CN minus AM times BM. Is this fine?
Yes.
Okay, fine. And now, what is the power of the point N and M with respect to the circumcircle of triangle ABC? So look, now they are inside the circle. Like let's work on with the point N.
AN,
So
AN minus AN times NC.
okay, so the by definition the power of the point is the distance between the center. The center is still O n square minus the radius, that is r square, which is equal to, by the intersecting chords theorem, yes, what just Ryan said was is an uh,
Times
negative
CN.
of, sorry,
AN
negative of an
times.
times cn or nc. Okay, and so I just multiply the negative thing out to make it r square minus on square. And similarly, what is the power of this point m? What do we get from there? That will be am times mc is equal to r square minus om square, where r is the radius of this circumcircle of triangle ABC. Is it clear? Okay. So now what I am going to do is I have this an. You see here I have an, cn, am, b. Did I make a mistake? am, cm. Yeah. Okay.
Sir, in the power of the point, I think AM times MB.
Am times oh sorry, yes, am mb, yes, yes, the chord is ab, so am mb, right. Okay, and now what's the next thing? So I'll just try to replace it there, right? So that means I'm getting, so let me remove something. Let's remove this part. So now this thing, I'm continuing with this thing, that is equal to 1 by 2 mn. ANCN is this r square minus on square minus this AMMB is r square plus om square. So it's finally boiling down to 1 by 2 mn, r square getting cancelled out, om square minus on square, and that is equal to half 1 by 2 mn om minus on times om plus on. And now look at om plus on, that is mn, right? So half of 2 mn times mn times om minus on. Okay, now you see that all I started with was o dash d. So this om getting cancelled out. Now om I can write it as OM. I can write it as uh, MD plus OD. See, half of MD plus OD, and ON I'll write it as, this is OD, and ON I'll write it as DN. Why I'm doing this? Because I know these are midpoints, so MD and DN will cancel out. So DN ON. So DN minus O dash D. No, just a second. Sorry. DN minus OD. So DN minus OD. So this MD and DN are equal. So they would basically cancel out, and I'll get 2 OD. And I have a half outside. So this is basically boiling down to OD. And so I have O dash D is equal to OD. And that's not possible until unless they are equal. So O and O dash coincide.
Sir, how do you know that O dash is not on the opposite side of the?
Okay. So you're saying that suppose the circle was something like this and O dash was on the other side, or maybe O is on the other side of this and O dash D is equal to OD.
Something like that.
Okay. Suppose, let's try to, yes, you are correct. So we can also contradict that fact. Suppose mm, I say that, okay, I'm removing some of the things here. So I say that the distance MO is lesser than NO. Okay. So if this happens, so that means O lies on this side. So if MO is strictly lesser than NO, then you see both O dash D and like just a second, O dash D and OD. Just give me 2 minutes. Can we do something with the power of the point? O and O dash. I have to somehow prove that this, if this happens, then O and O dash will lie between M and D.
Sir, I'm sorry for asking this question. Could you please move on if possible?
No, 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 this question should be answered because otherwise the whole thing doesn't hold. So uh, those who want may leave, because I'm not going to do something new because we are already done. So just trying to figure out this last part. And if I'm unable to do this, if I'll think about it later and I'll let you know in the classroom. So
Sir, can you send over classroom?
yes, I'll send it in the Google Classroom then. Yeah, so I'm ending the class here. If I figure it out, I'll send it in the Google Classroom. Okay.
Thank you, sir.
Okay.
Good night, sir.
Good night. Okay, so the logic behind it is that this thing, see, when we are applying the Tolerance theorem, look at the direction, the clockwise. So we are considering that the anti-clockwise direction is the positive direction. So O dash B is in the anti-clockwise, then EF is in the anti-clockwise direction, right? And now O dash F and DE, that's both in the so let's also write them in the anti-clockwise direction. So this will be F O dash and DE times DE. Okay, and that is equal to O dash E times. So O dash E is also in the anti-clockwise direction. I'm going from O dash to E, then D to F. That's also in anti-clockwise direction. So then O dash D is equal to, I'm dividing, so O dash E by EF times DF minus A, okay, let's consider F O dash by EF times DE, and this implies O dash D is, so I'm replacing those D, F and DE. Okay, so and now, okay, if everything is considered in the direction, then let's take, we are replacing this df, sorry. Okay, so if you consider everything in this anti-clockwise direction, so finally you are getting this to be OD, right? And that implies that according to the direction, so just try to figure out the sign. So according to the sign, so it implies that uh, like OD, since I took O dash D, so is equal to OD. So both, if both are positive, then both will be positive. If both are negative, then both will be negative. Okay, because all I'm saying is that the distance from O dash to D is equal to the distance of O to D. So if they both are positive, so that means they lie on between D and N, and if they both are negative, that means they lie between M and D. Okay, and that's the thing. So if MO is lesser than NO, then both OD and O dash D are negative, and that implies O and O dash lies between M and D. And similarly, if NO is greater than MO, the thing what we worked on, that happens, that both are positive then. So that's why I mean they are on both the sides. So just try to check the sign. So where the sign is changing, like till here we were fine, and then O dash D will be equal to half of. Now I'm replacing this AN by MN. So yes, the main thing will come is, so I can take them to be AN. So NA by, let's write this as NA by NM, and AM by AM by uh, AM by NM, and this is here NM, and we have their NA, DF, AM, DE, and now let's check. So DF, DE, fine, and now this is NA, this is NM, and what about CN? CN is in the anti-clockwise direction. Okay, now AM times, let's write it as MB, and there we are getting 1 by 2. So all these are NM then. Okay, and the point N. So NA times, let's take here, let's replace this, that is NA times, or AN times NC. Yeah, AN times NC is fine because both are in opposite direction, so they become I mean negative negative becomes positive, and AM times MB. Okay, so now this ANNC can also be written as NA times CN, right? So considering the positive direction, so Na times Cn, Na times Cn I have here, and AM times MB I already have it here. Now the rest of the things follows. So this is NM, 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 and everything will be in order of that anti-clockwise direction. And so whatever be the sign of O dash D will be the sign of OD. Okay, so that's how we prove that both O dash and O lies on the same side of the point B. Okay, so that proves that those 2 points are equal.